Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to vectors, the multiplication of vectors. And in the previous few videos, we covered our discussion related to dot product. Okay, dot product or scalar product, it is called. So in the next few videos, not few, we'll be discussing about a lot of things related to it. So 6 to 7 videos will have to cover this the second part, which is cross product. Okay, cross product, or it is also called as vector product. Okay, so these two multiplications of vectors, they are of two types. Okay, multiplication of vectors. First one, dot product or scalar product. Second one, cross product or vector product. Now in the first one, what happened was the result of the multiplication of the two vectors, it was a scalar quantity. It was a scalar quantity, only magnitude, no direction. But in the second part, the cross product or the vector product, the quantity which we will get is a vector, which means it will have magnitude plus direction. Okay, so sorry, let us say that we have a plane. Okay, xy plane. Let's say we have a plane and in that plane we have two vectors confined. Two vectors, let's say we draw it from here. Let's say this is A vector, this is B vector, and the angle between them, the direction of the angle, pay attention to the arrowhead which is placed, it is directed from A to B. Okay, the direction of the angle is in this way, from A vector to B vector. So that is very important. Okay, so this is the xy plane. Let's say we can take any plane. So we have two vectors confined in it. Okay, now the vector product or the cross product of these two vectors, it is represented as A vector cross B vector. This is the representation, the mathematical representation of cross product or vector product. So the result that we are getting, this is also a vector. Now again, a vector has two requirements. First is magnitude, second is direction. So let us call the resultant vector as C vector. Okay, the cross product of A vector and B vector gives us C vector. So the magnitude of C vector, it is A B sine theta, or it is A vector modulus B vector modulus sine theta. That is the magnitude of the resultant vector. Now the most important part, which is direction. What will be the direction of this vector? Now the direction of this vector, it will be in a direction which is perpendicular to the plane, or perpendicular to both A vector and B vector. Okay, it will be mutually perpendicular to A vector and B vector. So it will be like this. This is C vector, A vector cross B vector. Now here, whenever we are discussing a cross product or vector product, there is very much importance which is placed on which direction, which vector comes first, okay, and which vector is second in the cross product operation. So here the first vector is A vector, this one, that is first, and B vector is second, and that's why the direction of the angle theta is like this, from A vector to B vector, as if it is trying to rotate A vector in the direction of B vector. Okay, and this direction of the resultant C vector, it can be given by right hand thumb rule, like this. Okay, let us take it upward here. Okay, let's keep it here. Okay, so the direction of the resultant vector, it can be given by right hand thumb rule. So here imagine, let's say we have the two vectors. Okay, we have the two vectors here. We have A vector here, and here we have B vector. So pay attention to the direction in which the fingers are curled. Okay, it is here, like this, like this. This is the angle theta. This is the angle theta, that is A vector to B vector, A vector to B vector. That is the direction of angle theta. So if this is the way the vectors are oriented in a plane, so the direction of the thumb, that gives the direction of the resultant vector. The direction of the thumb is upwards, like this. C vector, that is equal to A vector cross B vector. Here A vector comes first, B vector comes second. Direction of angle theta is from A vector to B vector, first to second. Okay, this is first, this is second. Now let us say that we change the order of the vectors. Okay, we change the order of the vectors. Let us say that in the same plane we have, imagine this plane, okay, this plane, and we have the same two vectors. Okay, from here this is B vector and this is, let's say, A vector. But right now the direction of the angle theta is like this. The direction of the angle theta is like this, from B vector to A vector. So here B vector is first vector, A vector is the second vector, and the vector operation, it is trying to rotate B vector in the direction of A vector. So in this case, the cross product operation will be something like this: B vector cross A vector. B vector is first, A vector is second. Okay, now such a vector, let us say we call it as C dash vector. Okay, let us call it as C dash vector. So here again, this vector has two components, magnitude and direction. Magnitude is same, C dash vector modulus, it will be BA sine theta, which is same as AB sine theta, but the direction of C vector will be opposite to that of the direction of C dash vector will be opposite to that of C vector. So it will be like this, exactly pointing downwards like this. This is C dash vector, which is B vector cross A vector. Now this point, it can be emphasized again by the same right hand thumb rule. Here the one thing which has changed is the direction of the angle theta. In the first case, the direction of the angle theta is from A vector to B vector. That's why A vector cross B vector. A vector is the first vector, B vector is the second vector. But in the second case, the direction of the angle theta has changed in the opposite direction. Now it is from B vector to A vector. B vector is first, A vector is second. So this again can be emphasized by the right hand thumb rule. So here, if like this, okay, this is B vector and this is A vector, okay, theta. So now the direction of the resultant vector will be again given by this extended thumb, which is C dash vector, which is B vector cross A vector. So the order in which the vectors are multiplied using cross product, that determines the direction of the resultant vector, but it has no impact on the magnitude. The magnitude is the same. So here the direction of curl of the vectors, the same right hand, when it is inverted downwards, the direction in which the fingers curl, they rotate B vector into A vector, whereas in here it is rotating A vector in the direction of B vector. Here it is rotating B vector in the direction of A vector. So here the resultant vector has the same magnitude, but it is directed in the opposite direction as compared to the first case. Okay, so this is the basic principle of vector product or cross product. Okay.